So I just wanted to welcome you again. You probably heard about this and decided to come along to this webinar because you are a parent and either you're homeschooling or you're tutoring your child at home, or possibly you even have a tutor that's using our approach. And either you have children with learning differences or you just know that they need to be taught maths in a different way. If we haven't met yet, some of you I've met already. But my name is Esther White. I'm the founder and the CEO of Maths Australia. And you might call me a seasoned home educator in terms of the fact that in the year 2000, so 24 years ago now, I decided to home educate my 5 daughters. And fast forward, I can attest for you that the way that I taught them maths, which is the way that I'm going to share with you tonight, they all have said to me that the pieces that they learnt with learning this way actually has been the parts of maths that they've actually retained into their adulthood and they actually feel really confident with. So basically from there, and then I've also done specific studies in dyscalculia with an organisation in the UK, and also have been to countless conferences as I was actually distributing this particular maths program and going to conferences and hearing professors, hearing people that were researchers in maths talk about the most efficient and effective way for us to teach children, and actually just saw with that this, I suppose, different themes that I'm going to share with you a little bit tonight that enable us to take maths and teach it as a language. So I'm going to be able to share some of those pieces tonight, even though we've only got 45 minutes or about 40 minutes left together. After going to these conferences, I also then developed my own methodology based on this program that I'd learned and this way of teaching, and then seeing researchers talk about the importance of us teaching, in a hands-on way, in a multi-sensory way, teaching sequentially, teaching in an explicit manner. And the key piece that I'm going to be able to share with you tonight is the ability to be able to take that and put it into your practice. And really, it's this part where we're going to take maths and make it easy to understand. And it might be a little bit of a different, or maybe an unusual concept, but imagine if you can imagine your child's life even, and your life, if they were loving maths, if you didn't have any maths anxiety for them or for yourself, or if you were actually able to work with them with maths and know that maybe the problem wasn't with them, and that maybe you think they don't have a maths brain or you don't have a maths brain, but if you were able to work with them and realize that that wasn't the problem, and that the problem actually was simply the way that we've taught maths. So let's go over to our slides. And as you know, we've come to learn about the simplest and smartest way to teach your child maths. And I just wanted to share with you, first of all, our vision at Maths Australia, which is to give kids life choices by teaching them maths the way that they learn. And that's really what I'm going to share with you tonight, is this opportunity that you have either as a parent or somebody who's supporting parents to be able to teach maths and make it simple. It actually is the simplest language, the simplest subject to learn on the planet. And the reason I'm saying that, and I can say it so confidently, and even if you think about it, if you think about the language of English, and if you just pause a moment for seeing, okay, is maths actually a language? But if I was to show you that maths is a language, if you think about any other language that you've ever tried to learn, and particularly the language of English, English has so many exceptions, so many rules that you have to relearn, so many ways that different words can be put together, so many ways they can be spelt, whether you're looking at British English or American English. There's so many combinations, and even then you're not necessarily going to be certain of your answer or certain of the way that you've written it. So the beauty of maths is, for example, a 2 plus a 3 is only ever going to equal 5 based on a same unit of measure. So if I've got 2 units of something and I'm adding it to 3 units of something, I will never get anything other than 5 of that same unit. So really beautiful thing. And I'm going to, share a bit, and I'll be at some stage tonight, we'll also come over to my little camera here and I'll show you with these blocks the ease and the simplicity, and you'll, seeing the blocks, you'll go, oh, I've seen those in part before, but you'll be able to catch this vision. So tonight we're going to go through what is maths, and then we'll look at, as we've shared with you and what's drawn you to here tonight, is what is the simplest and the smartest way for us to teach maths. And I know the word smart, sometimes if we say it's the smartest or the simplest, we're not saying this is the only way to teach maths, but I do know from my experience of 24 years with my own children and supporting thousands of other parents and home educators and intervention specialists and tutors and teachers and specialist teachers, that this is actually the simplest way to teach and the smartest way, because we're actually able to bring in research when we teach it as explicitly as I'm going to share with you. So what I want to see is, if you were to, and I've talked a little bit and hinted about this a little bit, but if I was to say to you, what is maths? What are some things that you would actually come up with? Or if you asked your children, what is maths? What do you think they might come up with if you were to ask that question? Numbers, great, thanks Melissa. Numbers and finding patterns, exactly. Yep, so they're numbers. And so the piece that Caroline's, my child would say boring and hard. Yeah, it's like, that's generally, when you look at that though, it's because we haven't actually taught them in the way that they can understand. So, but yes, it's definitely a theme that we often hear children say, is that maths is boring or it's hard. So either they've lost interest because it's too difficult, or they've lost interest because they already understand what we're trying to teach them. You think about what maths is. So Melissa's put their numbers. So, there are these things that we call numerals or numbers, our 0 to 9, and, bigger numbers that we can count, and our plus signs and our little symbols. And one piece to see with maths is that we do have these specific symbols. If you think about maths as well, I was just talking a couple of weeks ago with the gentleman who's a head educator for a prison, and he was saying he had a gentleman who was 35 years of age at the prison who wasn't able to tell time. So, something like time or understanding time, it has to do with maths as well. Maths is being able to, measure a distance from here to where I'm traveling, from here around the world. I know Annalise, who's on tonight, she's over in Vietnam, and, they've had to travel a distance and had to buy a ticket to be able to get there. And, maths actually is a part of every single part of our lives and our everyday. I was at a maths conference just on the weekend and was talking to a science educator, and she was saying, there's no science that can be taught devoid of maths. You have to have maths when you're teaching science, because if you think about, chemistry or physics or biology, all of them are going to use maths in terms of understanding size of something, the distance between something. If you think even of other subjects like geography or history, maths is in everything. So the key piece I'm going to talk about today, though, is maths being a language. So let me just define this for you, because this is going to be a really key component. And if you can grasp this in light of these manipulatives that I'm going to show you, you'll start to see the power in understanding this piece, because you'll realize that the squiggles that we use that are on the piece of paper that we often go to way too quickly, they're squiggles that have absolutely no meaning to our students. So say, for example, if you've had time to read this definition, but if we look at maths and we see it has its own set of symbols, that enable us to communicate. So let's look at this in terms of these symbols. So does anybody recognize any of these symbols in languages that you already understand? Can anybody speak Japanese or French or Yiddish? You know, all of these symbols that are here are actually languages or symbols from particular languages that tell us something. I'm going to show you what this actually talk about. Even if you look at the CHIEN, the AUB, the EEY, we might be familiar with those symbols, like we're familiar with the letter C, the letter H, the letter I, E, and N, but we wouldn't actually know what that means because that's written in a different language. Do you get what that little piece, just that I'm saying there? Do you get that bit that these are just symbols? They don't mean anything at all to us until we know that language. Does that make sense? Yeah? Great. Okay, wonderful. Thanks for that. This little animal, a dog, is actually what I talked about in that particular slide before. And in our language of English, we use these symbols to communicate the dog that I touched, I felt, I saw, maybe became my best friend. Then I showed picture books and I pointed this dog out when I walked down the street so the student heard the dog. But then we finally got to the stage where we wrote de, o, g. But do you see these symbols aren't the dog? They're just the symbols that we use in the language of English to represent the dog that I touched and felt and saw. I know what a dog is. Really key piece for us to see, because when you look at maths, and now if you look at the symbols that we use for maths, so let's look at these symbols. Our 0, our 1, 2, 3, all the way up to 9. Our plus sign, our minus sign, our division sign, our multiplication sign, and all the other symbols that we use in maths, they also have absolutely no meaning. So if you've got a piece of paper in front of you, I invite you to write the word dog out. Write d-o-g and see there's no meaning in them. Then write 0 to 9 and the plus sign, the minus sign, etc. And see that in those symbols, there's absolutely no meaning as well. So the key piece to see this is where these are abstract symbols. They don't have any meaning, but we have to give them meaning. The same way that we teach a language to a student, we have to actually have something concrete that I can touch and feel and see, and it's going to be accurate. So it can't be random. It has to be accurate so that when I get to those squiggles on the piece of paper, and I want you to see that's what they are. They're just squiggles on the piece of paper. And particularly if you put yourself into the shoes of your students and your children that are struggling, they look at those squiggles and they mean nothing. Especially if we've just gone straight to the squiggles on the piece of paper and tried to teach memorization, and we've used words and we've used some sort of random manipulative maybe, or something that, you know, let's count ducks or something. But the student, we haven't taught them explicitly enough so that those symbols make sense and mean something. Does that make sense? Are you starting to see this part where the squiggles on the piece of paper are just symbols in the language of maths, same as the language of English or French or Japanese or any other language, and they don't have meaning until we attribute or until we show meaning. So what I want to share with you, now that you've just got that piece and you're seeing maths is actually a language, and you know, you've probably heard of maths referred to as the universal language, but now what we're going to do is we're going to look at what do we know is the most effective way for us to teach a language, and we're going to take that knowledge and be able to put that into how we teach mathematics. So let's get started just on this little piece. And this is where you're going to actually use that PDF, that template that you've been shared. I'm going to actually explain to you each of these components. And this is the research or the result of the research that I've done over the last 24 years. And this actually encapsulates each of the components that you need to be able to teach maths effectively. So let's just go through each of these components, and then we'll, as I said, I'll show you the blocks as we go through some of them. So when we look at the I is when we're going to identify. So if you think of identifying where somebody's up to be able to teach them, I mean, we do this all of the time with our children. We identify what level of understanding do I have in what I'm about to teach them that enables me to have something that I can build on. And I noticed some of you are from schools or are teachers as well. And you would do this as well. You would identify, you know, do I have prior knowledge that I can now build on? We're not going to teach, for example, a year 2 student something that a year 5 student would be learning. So the first place that we're going to start with is the I for identify. So we want to see in this sequence of instruction that we're going to walk through, where is a student currently placed? We're basically going to say we can't teach multiplication until we've learnt what counting is, then move to addition, which is fast counting. Then we can move to understanding what multiplication is. And basically, we're just building bigger rectangles. So we have a placement test that enables you to very simply have the student walk through, and you're going to watch them and you're going to see, you know, do you understand this with ease? Have you progressed from using your fingers to count or some other form of unit counting? Can you actually add, for example, a 2 and a 3? And instead of having to go 1, 2 plus 1, 2, 3 is 1, 2, 3, 4, 5, or even counting on, we want them to be able to add and to see this is 2, this is 3. If I add them together, they're only ever going to be the same length as or equal to 5. So our placement test is going to assess, have we mastered counting? Can we add? Can we apply this in our everyday life? Do we understand place value? Can we subtract? Can we multiply? Can we divide? Do we understand whole numbers? And now we can progress into understanding fractions and decimals and percents. So really key part that I saw in research is that they say there has to be a focus on whole numbers before we can progress a student. And we need to teach explicitly. So really key piece is ensuring that we're teaching in a particular sequence, and then we can also teach them with having established foundations before they progress. The beauty as well that I just want to share with you when you teach this way is that you're never going to have to go back and fill in gaps, because we're really incrementally teaching and making sure, have we mastered this? Now we can progress the student. So regardless of their age, we're still going to say, if you can't add, or you don't understand place value, we're going to start you at this stage, then we can build on from there. And we're going to, obviously, as you can see, fill the gaps. I just wanted to share this with you, and we will send this in an email to you, but this is the link to our placement tests, and they're just free placement tests. I just noticed Bethany's put into the chat as well. So you're able to do that and have a student progress through that, and whether you choose to work with us or not, you're still able to assess where is your student up to in this sequence of instruction. You know, sometimes it can be quite eye-opening, sometimes somewhat disturbing. I mean, I remember back when I was homeschooling, having a dear friend who had just bought her maths for the year and decided she wasn't going to use this approach. And then she tested her students, her children, and she decided, okay, we'll do the test again at the end of the year and see where they're up to start this methodology next year. When she did the testing the following, like the end of that year, her students were at exactly the same stage that they'd been in at the beginning of the year, and basically saw, you know, we could have just taken a year off maths, or that they didn't actually learn anything else, even though they were progressing through curriculum. So you would have seen that quite likely as well, where a child can progress through a book, but then when you look at what level of understanding do they have, they actually haven't improved, or they haven't understood. So really key piece. And as I said, this is a great little test place for you to do the testing, for you to be able to see where your students actually are. So let me just get some water. Okay. So let's go on to the next piece, the C part of this. And this is a sequence of instruction that I'm going to show you. You may have heard of the CRA or CPA approach. Have any of you, if you want to pop into the chat, heard about this approach? And then I'll just know how clearly I need to share this with you, because there's quite a different approach that I'm going to share with you in regards to this way of teaching. So our C part is the concrete, where we're going to actually, thanks Anushka, I just saw you haven't heard of it. So the concrete is the three-dimensional, where we're going to actually build, and these are the little blocks I'm going to show you later. A little unit block, a little 2 block, where is it? There's the camera there. And you'll see that you can see and feel the demarcations on these, the 3 block, etc. So I'll be able to show you that. Yeah, so Rachel's put in their concrete pictorial abstract. So as I said, I want to show you the key piece with the concrete that we're going to talk about, and I'm going to demonstrate shortly, is this part where we're going to build with the blocks every time we start a lesson. So we're going to have this knowledge from having built and touched and felt and seen and worked with something that our body can remember and that we can visualize as well. So we're learning through our touch and our body memory, but we're also learning through creating images. And if you think of, you know, the last great book that you read, the book was fantastic because it enabled you to create images or create pictures. And with these manipulatives, with these blocks that I'm going to show you, you basically can draw or create an image with maths where you're building rectangles every single time. And it's a very, very simple approach that enables you to bring the language in, bring understanding from everyday life in, and then you're going to teach explicitly and accurately so that the student understands. So that's the C. The C is for the concrete, the building stage. Then we're going to go into what we refer to as the representation. And if you saw in Rachel's comment there, she said pictorial. The key difference here is that you're going to actually have the student draw their own picture or their own representation of what they've built. And it has to be consistent with the colors that they're using. It also has to be accurate proportionately. And I need to say this because I even saw a book written by a dyscalculia specialist where they had, for example, a number like 321 or something, and the 300s were there, the 2 10s were about half the size of the 100, and the 1 unit was about 1/3 the size of a 10. The key piece there is that student wouldn't have had any understanding of the difference between 300s, 2 10s, and 1 unit because they weren't proportionately accurate. So really important piece is you have to have the student draw a picture before they go to the abstract. So that's our next step. The A is for abstract, where instead of us teaching squiggles or trying to cram maths facts in when we know particularly students that have learning differences, they have difficulty with cognitive load. Instead of teaching squiggles and memorization and rote memorization and trying to cram maths facts in, we're actually going to teach these symbols that relate to what we've built. And as we said before with the maths language, is that those symbols on their own don't have any meaning. I mean, if you were even to look at a 0, you would think it doesn't tell me that there's nothing there. There's actually a whole lot of space contained within that 0. The numeral 1 might be able to, but that would only be 1 if it was one long skinny pencil. It wouldn't be one elephant. It wouldn't tell me. I couldn't look at that and see that's 1 and 2 is 2, because if I was to logically look at it and put myself again in the shoes of my students, they would look at a 2 and would have no understanding of what that actually was. So that's a really key piece. I want you to put yourselves into their shoes and see, why would I even think that you would have even any understanding of these numbers, even if I'm going to teach counting, and we'll look at that shortly. But just this piece where we have to give an accurate understanding so that when we talk, our languaging is accurate and the symbols that we use now have meaning behind them. Great. Okay, so now comes the fun part where I'm actually going to show you some of these sequence of instruction that we want you to go through. And I'm going to show it to you with these little blocks that I have. So let me just come over to here. First of all, let's just look at this slide. So when we're teaching counting from 0 to 9, we're always going to begin with 0. And it's a really key piece where so much of the time when we teach counting, we start with 1. But if you think of place value and our hundreds, our tens, and our units, which is our repeating pattern in our base 10 decimal system, in each of those places, we can only have from 0 to 9 numbers or numerals. We can't have 10 in that. So when we teach 1 to 10, we're not teaching to the pattern that there actually is within mathematics. So that's a really key piece. We're going to start with 0. And we're also going to see that 9 is the biggest number that we can have in each place. And we're going to see this direct correlation between the concrete and the abstract. So one of the key pieces when I show you these little blocks is that I want you to see that the blocks are exactly the same. So you might have tried to teach your child how to count, but if you had buttons that, you know, had all different colors or different shapes or different number of holes in them, or different sizes, or any other differentiations, your child, particularly if they have learning differences, but anyways, for any child, they're going to look at that and see a myriad of different possibilities. So what we're doing here is we're simplifying and we're saying, we just want to teach you how to count, and we want to teach you the words that you're going to hear when you're counting, because these words even are abstract. Okay, so if you look at these little blocks, when we're teaching counting, we're going to count either left to right or right to left, but you'll see even with me having these in a line, they're much simpler for me to learn to count and to remember than if I have them randomly all over the place. We'll get to that at some stage, but when we're teaching counting, I'm going to actually count left to right. I'm a lefty. So I would say this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And a key piece to see with this is, say, for example, this number 3, if I was to point to this isn't 3. This is only 3 because I have 1 and 2 before it. So that number there, if I point to this now, this is 3 because I have 3 units that are joined together. So really key piece. And when you look at counting, particularly in the training that we offer, you'll see there is so many components to teaching counting, even like what we call one-to-one correspondence. You know, I can point here, that's 0. I point to this is 1. I point to this is 2. So do you see with this though, when we're teaching counting, we're actually really just teaching the student what are the words that we use when we're counting in the language of English, but we're counting maths, we're counting numbers. The key piece I wanted you to see for that was that the counting requires me to simplify what I'm using to count so that there's no other information that the student's going to see. We're just teaching the sequence of words and the symbols. We'll get to the symbols, but we're teaching the symbols that we use when we're actually working in our language of mathematics. I've used 0 and then 1, 2, 3. So they're quite abstract words, and you wouldn't know that unless you're actually going to teach this so clearly. So place value, from when we can count, then we can teach a student place value to our hundreds and tens and units. And it's a repeating pattern. We're speaking left to right, we're writing left to right, and really interesting to teach the student these exceptions. And this really starts to make sense when you see why students maybe don't understand our teen numbers, where, you know, we've said 70, it's telling us we have 7 T's or 7 tens. Then when I get to 13, for example, there's a whole other word that isn't actually accurate in terms of the other languaging that we've used, and we have to introduce this concept of a nickname. So we don't quite have time to look at that right now, but I just want you to be mindful of that the words that we use when we're teaching number the way that we generally teach, beyond 10 to 20, they're our most inconsistent numbers. So what we want to do is we're going to teach 0 to 9 counting. We're going to teach hundreds, tens, and units, and then enable the student to, from the concrete, from the hands-on, from that manipulative, see how many hundreds, how many tens, how many units do I have, and be able to decode and understand those numbers. Okay, so let's just look at this part on addition and then subtraction. So really key pieces, and because I'm teaching this part to you on the language and maths being a language, if you think about your plus sign, it's 2 lines that are brought together, yes? So every time we're adding, we're actually bringing 2 numbers together, and we're going to see what are they the same length as or equal to, and we're going to actually build an equal sign. So let's come over to this again. Okay, let me show you this example here. So say I had 2 plus 3, so I know, oops, let me see. I know that this is 2. It's 2 units that are joined together, and we actually have walked the student through that explicitly and very clearly. So this is my 2. When I'm adding 3 to it, I'm bringing them together to see what are they going to be the same length as. And let's get our other blocks out. So say, you know, we've walked them through understanding what these blocks are. Are they the same length as a 4? You can see that they're not, are they? We know this is a 4 because we've walked through that beforehand. This is a 4. 2 plus 3 is never going to equal 4. What about my 6? Is it the same length as or equal to my 6? It's not, is it? But this is a 5, and I've just built that 2 plus 3 is the same length as or equal to 5. It will never be anything else other than that. So basically, what you're doing is you're starting with the concrete. You're going to then draw a representation, as I was saying. So you would actually have them draw. Here's my little 2 block. Here's my 3 block. And you can see it's pretty much proportionately accurate. And then I'm going to draw that that's the same length as or equal to a 5 block. So I'm actually making a transition from this that I've built to this, to then being able to see, let me just zoom out a little bit, to then being able to see, I can write this as 2. I know that this is 2. I'm going to put a plus sign here. This is 3, and it's the same length as or equal to, because I've just built an equal sign here, my 5. So I hope you see with that, you've actually taught a language. You've taught that these symbols, I can actually take them from this code form and make it into something that's concrete. I've drawn the representation. Now I've got the abstract. So here's my concrete. Here's my representation. Here's my abstract. And it's a really, really accurate way that we can teach explicitly and clearly to our students. So let me just see, I just noticed somebody pop something in the chat. Okay, great. So let's just go on to the next piece, and let me just take this off here. Beth, if you can take us from there. Actually, let's come back. We'll stay on this part here, and I'm just going to show you multiplication. And you may have heard of multiplication being taught as arrays, but let's just look at this. We're actually going to teach multiplication in this way. Let me just zoom back down again. Okay, here we go. So this is multiplication, where we're building a little rectangle. And we can see this, we could count them, and we actually walk through a process of skip counting to see this is a rectangle that's 2 across and 5 up. And inside this rectangle, we have 10 little square units. So once again, every time we're teaching a new concept, we're going to introduce the symbols, and then we're going to actually show in a concrete way, walk through the representations, then the abstract actually has meaning and understanding behind it. The verbalization is essential because the student has to actually hear themselves speaking, and they need to actually understand from that perspective what they know. And you can, when you've got this dialogue happening with them, you can determine, have you been accurate in your instruction? Have they understood? Or are you needing to give more instruction? But they also have shown through research that a student needs to hear their own voice explaining something. It's a very different way that we learn and retain much more knowledge when we hear our own voice. So when we come to the E part of I Crave, we're going to teach explicitly. So the key piece here is it needs to be accurate, it needs to be consistent and precise, and we need to be able to know that we've established foundations that we're not going to have to undo. We're never going to teach a student how to get an answer that's not based on something that they've built and they can see. That's a much stronger place for a student to come from. They have confidence that they wouldn't have actually otherwise had. So I'm just mindful of the time, so I'm just going to go through, and I just wanted to share with you what we were talking about today. So this maths program that I said many of you would have heard about, and that engages our senses. So we're teaching in a very truly multi-sensory way. It improves learning retention because we're actually bringing in every single learning style and every sense, every way that we bring knowledge into our understanding. So whether that's through touch, through sight, through hearing, through movement, all of these parts are integrated into this. We're allowing the students to learn at their pace, and we're going to actually build confidence and enthusiasm because they come to see that the problem hasn't been with them, it's just been the way that we've taught them. And, you know, I can say this with confidence with students, whether they're really low in their levels and have learning differences, or if they're what we term, neurotypical, and they actually don't have any known learning challenges. But what we see with children with learning challenges is that they actually teach us the most effective and accurate way that we need to teach. We can't give something that's not actually accurate for them. So what I wanted to share with you tonight, and I'd mentioned I was going to be sharing this with you, is that this package that we've put together, and it's been put together so that we can actually share with you everything that you need so that you'll be set up for success when you're teaching. So there's a manipulative block set, this beautiful set of blocks that I've shown you that's got all of these units all the way up to tens and hundreds as well. It's got a big block clock template and the lesson by lesson videos that come with this, an instruction manual and a student kit. And those components are particular to where your students are up to at the moment. So the package that we put together was basically we saying you need to do a placement test, and then from there we can determine which level to begin with, and you'll need these for whichever level they're up to. We've also included a coloured pencil kit. So basically you can see this behind me. This is a pencil kit that's got all the colours in it of the blocks, and basically it's that we're using colour and a consistency of colour to support the child to learn and to retain knowledge. Same as we use, we know colour is basically the only way that differentiates money for us. So we're going to use this with the blocks and that consistency of colour that's going to enable them to retain that knowledge. You also receive a free consultation with Bethany with regards to your child and beginning your child, and also a free introductory course that I've developed that introduces you and ensures that you have all the components that you need so that when you're teaching, when you begin, you actually understand each of the parts, and it's similar in part to what we went through tonight, but also has a few other components that just really establish an understanding for you because you're taking on this role of being your child's teacher. You also get free shipping. So just before we finish, I just wanted to share with you this beautiful testimonial from a young man who's about 35 now, but he sent this through to me. And he, when he was in year 8, started at what we refer to as our year 1 level, so our alpha level. And he'll mention that he started at that level. He'd been told basically, go home, learn to work on your family property, you'll never really get maths. And then basically he's such a testament, and I hear this time and time and time again, of when he was taught in the way that he learned, he's now working as an estimator with a scrap metal recycling company. So I just wanted to share this with you briefly, and then I'll just come back and explain the offer again as well.
At school, maths made no sense to me. It was very confusing. I didn't understand the concepts, and it was just, I couldn't see how it related to life. I was introduced to maths grade 8 and redid all of my maths to year 12, and it really helped me because I got a good grip of what maths meant, what it meant to life, how all the patterns and everything worked, how everything suddenly fitted together, and it really helped me change my life. I work in a career now as a metal recycling trader and use maths every day to be able to negotiate with mining companies and metal trading companies, the foundries that I supply into, and I need to be able to do that and make a profit. And having used Maths UC, it has helped me be able to be successful in this role. So thank you, Maths UC.
So yeah, beautiful story, isn't it, from this young gentleman, and as I can share with you, like thousands of others that have been able to also learn in this way. So just wanted to go through again these parts, the manipulative block set that you receive, and that one set of blocks is the only set you need for teaching all of whole numbers. So when you're teaching place counting, place value, addition, subtraction, multiplication, division, we're just using that one set of blocks for all of the hands-on learning. So that's included in it. Then the lesson by lesson videos, an instruction manual for you teaching, the student kit for your child, and then also the coloured pencils, a free consultation with Bethany, our multisensory math specialist, a free introductory course that I developed and also free shipping. And it's actually just $499. Awesome. Okay, well, I think that's it. Really happy to have been able to share this with you. Hope that you'll be in touch with us because, you know, as I said, it's such an efficient, such an effective, such a easy way to teach maths. And, you know, I hear time and time again, I was even talking with a school recently where their children have started, you know, maths has started becoming the reward for them finishing everything else. So, you know, that's what's possible and really easily possible because you're teaching in the way that they learn. They're going to start to understand and you're going to fill in those gaps for them. So, yeah, great to have had you here. Thanks, everybody.